how much time and effort will this take? Now let's take a look at the inventory again. The inventory is 10,000 instances. First of all, to execute this task, Bo will not be able to do so because he doesn't know about other technologies. He may be skilled in AWS but not in OCI, or in Google Cloud, or on-prem versus the cloud, and so on. Maybe he's experienced in certain versions, or even products under certain business conditions. So the point of this is, in order for the enterprise to execute this, Bo would not do alone. We need to hire additional DBAs to do this. It's 10,000 instances, and since this is emergency, it has to be done fairly quickly. Now let's calculate the numbers for this. So to execute this piece of work, we need to hire four additional database administrators. So let's say 150,000 multiplied, let's not count the benefits, multiplied by 4. So before even starting this piece of work, what needs to happen? This needs to be accounted into the budget. Let's say $500,000. To hire these people, it will take approximately 6 months. So there's a time limitation now, because it takes time to hire, to vet, to basically to train people, get them approval, access to everything. So, but even with these $500,000 spent and 6 months passed, now let's see how much time this team, already complete team of 4 people or 5 people, will take to execute this. So 4 people multiply, I'm sorry, let's do this. So 10,000 instances divided by 4 people. So we get 2,500 instances per person. It takes on average 5 days to go through the life cycle of a change. So we multiply this by 5, and this is the number of days. Let's get the number of years, and we get 34 years to execute this change. So $500,000, 6 months, and for conventionally automated team, it will take so many years to execute. Now let's see how automation will execute. On top of that, let's talk about one more point, which is the error rate. So the speed is horrendous. We established that. Also, the cost is horrendous. But on top of that, there's one more indicator, and that is the quality of work. So the quality of work is, what does that mean? That means every time when there is a process that needs to take place, if an admin approaches the task without knowing the password, that's a quality hit. It's a quality basically negative. If he or she connected to the wrong instance, that's another error. So let's calculate that number. So an approximate human error rate is 4%. So 10,000 tasks divided by 100. Sorry, by 100. And multiplied by 4. No, that's incorrect. Sorry. So let's do this again. 10,000. Okay. Divided by 100 and multiplied by 4. We're getting the percentage. So the question is, out of 10,000 change requests, how many will result in errors, delays? And we get the number of 400. That means in 400 tickets will have to be redone again by the administrators. So that is the limitation. Those are the limitations of regular regular automation or open loop automation. Closed loop automation, unlike open loop automation, it basically excludes any human intervention other than design. So in this case, let's see how hyperautomation performs. First of all, what we will see is that hyperautomation is exceedingly quiet. There was no need for anyone to open the change request. There was no need to open even an incident. Here's what happens. The automation starts basically the process. It opens an incident as a basically reaction to a threat. For example, doesn't have to be a threat. Could be an upgrade. Could be data center migration. Basically any IT related task. Then it opens an incident. It assigns the incident to the right queue, the right automation utility, and then it gets to executing it. So in this case, as we can see, hyperautomation connected um, to the servers. It got the naming convention. So as we can see, the numbers are 0006. Those are the numbers of the instances. It says AZU, which stands for Azure. DB SQL means the tool. So it's this hyperautomation utility basically resets the passwords in batches, all 10,000 in real time. So once again, what took or would have taken a team of DBAs so many years, and it would have cost the enterprise 6 months to basically to hire the people, and approximately $500,000 to pay the administrators to execute this task. This hyperautomation does in real time. No need to wait for 10 years. There are no errors, as we can see, because all of this is happening in real time. So, but let's get back to change request and see what's happening. So here's our manual ticket we opened for Bo. How do we know this? Here's the name. And these are the change requests that were opened automatically in response to an incident that was opened by hyperautomation. Here it is. So nobody even opened the change request. So what happened after that, and this happened after we started the demo. All right, so automation opened the incident, it connected, then it went to the inventory. It said, okay, so for this task I have, what do I have? It has AWS RDS, Azure, Google Cloud, Oracle OCI. So it opened 4 change requests in response to an incident. Each change request has tasks. So you see Database Atlanta and assigned to Replayable Hyperautomation. Replayable is a name of a product in this case. So you see that's what happens when you hyperautomate. You simply assign it to utility, automation utility, or you don't even have to do this. You can set this as default, meaning every time there is an incident automatically opened in Database Atlanta, only automation utility handles this and never a person. But let's drill down into a change request opened in response to an incident. So as we can see, incident number is this. That's the automatically opened incident. It applies only to AWS RDS password rotation, and the incident created the change request, and change request basically triggered 3, in this case, tasks. They're AWS specific. So there was 1 task for RDS Oracle, 1 for Postgres, all AWS related, 1 for MariaDB, and we can see they're already done, closed. So there was no need to spend $500,000, 6 months, and basically endure so many errors, and most of all this basically happened right away. But let's see what happened during each task. So each task was executed this way. The automation utility checked the basically what is the current password. It tested it. It recorded it. Then it checked what the password convention or password security rules are. It tested those for every of the 10,000 instances. It did this separately, and each one of them is basically each password, previous and current, is recorded inside an automation vault, which is basically just one source of truth. All right, so what happened is the incident was auto-triggered. It created change request, also auto-triggered. One for RDS, one for Azure, one for Google Cloud, one for OCI. Each change request contains tasks specific only to the inventory, software and hardware inventory this particular enterprise has. And then it proceeds to change passwords. For all of the instances, it basically uses its own utility. For Oracle, it's SQL Plus. For SQL Server, something else. For Azure, Cosmos is something else. So the details which utility to use are immaterial. What is important is that the process was done vertically and horizontally automated. This is vertical automation, which means the entire life cycle of a change, from reporting an issue to assigning to approving to routing and to execution, and all the way back up to checking the results, was automated. That is vertical automation. Horizontal automation means that the process of changing the password was done at the same time in AWS, in Oracle, Azure, Google. Even inside those products, it was done with different utilities in the correct way at the same time. So those are basically the changes, the difference between hyperautomation and automation. Automation basically helps an administrator to perform a task. Hyperautomation replaces that admin entirely. So let's see how much time this utility actually took for us. So it's still working. Actually, it is completing. This is okay. So we can see that Azure, Exadata, Cloud SQL. Now hyperautomation checks the results. Now it basically goes to the change requests and check if for each for each iteration of a tool, was it done correctly, and the answer is yes. And then it closes the change requests, and basically it updates the incident as resolved. So these are the results. This is instance number 1000. It was AWS RDS Postgres. So if there was a problem, this would not have been okay or wouldn't have been changed. So this is hyperautomation at work. Now let's see how much time it took. This is the number that tells us 113 minutes and 22 seconds. So under so it took us almost no time to execute this change, as opposed to so many months spent just to execute this. And we would have encountered so many issues, and probably a lot of things would have been rolled back and started from scratch. So, but this is the difference between hyperautomation and automation. Hyperautomation automates a process from top down. Automation helps an administrator to execute a task the entire process consists of. It is basically specific to a certain utility, usually within certain vendor, but it's not basically automates the entire process vertically or horizontally. So that is the main difference. All right, thank you for your time. This has been Vlad, and once again, automation is my passion.